attend. We quite regularly get international participants from different time zones. Okay, this session is being recorded. Thank you everybody for joining tonight for another INCOSE Canada webinar. It's my pleasure to introduce Matt McLean. Matt is with TraceSpace. Matt has been a systems engineer and is a longtime INCOSE member with experience across various industries, including defense, aerospace, and research environments. Matt holds a Bachelor of Science in Aerospace Engineering from UC Irvine and has held a systems engineering role in various areas, in various companies such as Anduril Industries, Georgia Tech, a Research Institute, SpaceWorks Enterprises, and Sheffield Aerospace. Matt began his engineering career with a prototype design internship at NASA's Jet Propulsion Laboratory. So, wow, what an internship that must have been. I can't imagine. His background in autonomous systems and embedded systems development gives Matt a strong practitioner's perspective on what happens when requirements management breaks down on complex systems. I think we've all probably participated in projects where there's bad requirements. In fact, I don't doubt, whether you want to admit it or not, you probably wrote a bad one or two, and this is everybody in the call. I know I've written a bad requirement in my past. So I'm sure there's a lot for us each to benefit from in tonight's presentation. With that, I'll turn it over to you, Matt. I ask that everybody hold on to your questions till the end, and we'll have a Q&A session, or put them in the chat and I can ask your question on your behalf. With that, take it away, Matt.
Outstanding. Thank you so much. And it's wonderful to be here with everybody. Thank you for having me out tonight. And yeah, we'll get right into it. So as was mentioned, I come from a systems engineering background. I'm our forward deployed systems engineer here at TraceSpace, and my job is to essentially speak the systems engineering language from the practitioner standpoint when we go to deploy TraceSpace as a tool. And so, I have a personal stake in the tool that we're deploying to our customers, and from my personal background, I've tried to build, a capability for doing what we're doing at TraceSpace on my own time, trying to solve real problems that we come across in our day-to-day life, and I just was always coming up short, and so that's what led me to join TraceSpace. It's a tool I wish I'd had, but here today I'm interested in talking about my perspective on requirements. A lot of this is informed by like customer-centered requirements or customer-centered products, Ivy hooks, a lot of your classic requirements, gurus and ideas. And so we're going to track through some of these concepts in real world use cases, and talk a little bit about how tooling has kind of fallen short of requirements, and how I feel about that. Yeah, we'll absolutely welcome questions at the end, and yeah, really excited to present to you guys. So thanks so much. All right. So without further ado, I will start my slides. Okay, so that's me. And one of the biggest problems that we've got is the volume of tooling and interconnectedness between them. We've got kind of a tool chaos. So, I mean, how many of us have been in a situation where like we're 2 weeks from a critical design review and someone asks, wait, where are the requirements? Where do they actually live? And someone's like, oh, they're in Jira, or the Confluence page from 18 months ago that no one's looked at, or there's 6 versions of, and this is the 7th version and no one's tracking it. Maybe it's in someone's inbox, or maybe it's in someone's head. And that's what we've got with this slide. So we've got IBM Doors, we've got Excel, Jira, SharePoint, Word, emails, tribal knowledge. Like I've been a part of this problem as much as anyone else as I've come across in the organizations that I've worked at, and that's just because this is what we've got. This is the landscape of the tooling that we have. And requirements management is a tough job. You've got a lot of work to do, and very oftentimes you're not given the resources or the time to get it done when by the time it needs to. And there, my perspective and my experience, I've always felt like there should be a different path. But this is something I think we can probably all uh, connect on. Um, Complexity has been scaling up for a long time, and I think anyone who's been in systems engineering for any period of time, especially in this day and age with the advent of AI, with increasingly integrated hardware and software systems, autonomous systems, et cetera, you go from systems which may have had a couple thousand requirements 30 years ago to systems that have 500,000 requirements, or they have 500,000 requirements spread across a dozen or so different systems. And so, this scale adds a quality all of its own to the challenge of requirements management, which is already difficult in of itself. And this is 100 times more the scale. And the shift isn't just the number, but it's the interdependence of different tools, of different sources, of different variations of products or customer needs. And fundamentally, they don't exist in isolation. Every single one of them is connected to dozens of other requirements. If you change one, the ripple goes far down the line. In many cases, disappears beyond the horizon of your organization, my organization, or some tool. And the fundamental problem, in my view, is that tools didn't scale with us. It's a mismatch between the problem we've got and the capability we have as engineers to solve it with the tools that we've got. And everything touches everything. This is another challenge today. This slide captures something that I tend to think about quite a bit, at least in a modern systems context, with automotive, aerospace, defense, industrial. There's common themes where software is more and more driving hardware, and there's this interplay between the two that is increasingly unavoidable. This was clear when I was at Anduril. GTRI radar systems have been doing this for a long time. And so for some folks it's old hat, for others it feels fresh and new, and increasingly overall it's just becoming more and more what is driving modern engineering. But there are things about how those integrations impact each other, right? You've got hardware that affects safety, and you've got lead times for hardware that software doesn't have to consider. And safety ties into compliance, and every requirement that you come across ultimately becomes connected to something that might be disparately related to a series of other complex web or network of requirements. And you can't really think of those things in isolation anymore. Every mechanical spec has electrical implications. Now they've got software implications. All of your hardware behaviors have safety cases attached because they're controlling some aspect of your hardware system. And when I was working on autonomous systems, we spent enormous amounts of time just trying to understand the dependency graph of all of these interconnections. This was part of what drove me a little crazy at Anduril, was trying to understand how changing these lines of code would impact the manufacturing of a drone, or how shifting the development of these hardware locations for boards might change the weight and balance, or might change the power draw, or the heat dissipation capacity, or the addition of a new feature in software is now pushing the hardware further than it could handle before when we designed it. I mean, all of these things that you could reasonably work through in a previous life or a previous time are becoming more and more and more integrated, to the point where the tools are just showing that they're struggling to deal with that and provide us with the utility that we need. And it shouldn't be manual work. And it shouldn't be people going through Excel spreadsheets. It shouldn't be people having to, like, red thread the whiteboard from one side, from one picture to another. But far too often that's the case. And complexity didn't scale. It exploded, and the tools we're using, spreadsheets, word processors, PDFs with scanned in, images of typewritten documents from the 70s, legacy platforms with no significant updates in UX or functionality. These are all designed for a world that's ages away. And the gap between how complex our systems are now and how primitive our requirements management is where a lot of cost lives, if not immediately with the delays in documentation or the delays in traceability. We suffer later down the line in the integration phase and the deployment phase of our products, because that's when the real cost of requirements mistakes shows up. And we want to catch those things earlier. We want to stop them before they get to that point. And most teams aren't carrying most teams aren't carrying a single big problem. They carry requirements debt, and we usually don't know the full scope of it. And it's similar to technical debt, but it's creeping. We've got a few requirements in year one that are undocumented assumptions, but we carry those through to year two. And no one's followed up since PDR on the handful of specs that were created. And then we've got a traceability matrix in year three that's, we think is right, but we're kind of trusting that those 3 years of work have been as thorough as we'd hoped. And then a couple of team members might leave, and you've got to onboard someone new, and they don't have that context, or whatever the case may be. Eventually, one day, you don't trust that the documentation of the system is what's there anymore. This was something that was rampant, not rampant, but what came to the fore in at GTRI when I was working there on radar systems. I mean, these ground-based radar systems have been around for decades. Documentation that was literally written on typewriters, and so you've got to process all of that information, and and then combine it in with your modern context for what you're trying to engineer. And this is what largely drew me toward like model-based systems engineering, because if I can lay flat everything across the board that I've gotten documentation, then maybe I can get ahead of this. Maybe I can get this into a form that is useful for me to evaluate the system and apply some kind of high level wisdom or effectiveness, and assess the requirements in the context that they actually exist in, rather than in the context that I hope for them. And that's the idea of requirements debt. Again, an idea that I think we all have experienced at some point. And this manifests with missing links, duplicates, ambiguity, outdated specs, unknown ownership. And these are 5 symptoms that keep coming up, especially in the discussions that we have with clients for requirements management. These are things that I've dealt with, that we hear about from time to time, in terms of the general struggle. They missing links, requirements that don't have tests or verification methods attached, or tests that don't have requirements. Like, we just wanted to build the thing, and we're testing it, and we just got to test. And it's like, well, okay, why are you testing it? Why did we build it in the first place? They exist in the system, they're approved, and we may even be executing to them, but there's literally no way we know if they're satisfied or not, because the trace doesn't exist. Additionally, you've got duplicates. I mean, we've all seen those like outdated versions of specifications that everybody's assuming that we're playing from, and lo and behold, there's a Rev G out there that no one knew about, and oh yeah, or there's an advisory circular that was just posted that invalidates the Rev of the spec, and the only person who would have known is on vacation. How do you know which one is authoritative? Do you get an alert when one goes out of date? And if the person who knows isn't there, how else would you know? And then ambiguity. This is like a personal favorite of mine, is the system shall support user input. Like, you know, if we're familiar with Ivy hooks and you know what the form of high quality requirements looks like, we only support things that have mass. And but I've definitely written a requirement like that because it was the fastest way to get the idea out of my head and onto the paper. And you know that requirement that stacks up because it's like, well, you know, we'll do a review, we'll get around to sorting it out. And you know, I've seen enough of the system shall support XYZ in, you know, final specs that I've received from customers to know that, you know, some of those things do fall through the cracks. And again, it's a place where our tooling really should pick up pick up that slack. And and then we've got the outdated specifications, um, you know, things that that you can't keep track of or haven't been updated in God knows how long. Maybe on the project, maybe across different projects, and then you finally got unknown ownership. You know, who's actually responsible for this, or maybe even better, there's someone who's written as being responsible for it, but then you can't get in touch with them, or they're retired, or they're on vacation, or what have you, and now you're kind of alone and unafraid, managing through all of these different challenges that we face with these with requirements debt. And we spend too much time fixing this stuff, man. Like the whole point of being a systems engineer, right, is not to wrangle documents, it's to consider the system and apply wisdom to the system. But if you can't consider the system because everything about the system is so disparately spread, then you can't do the thing you're meant to do as a systems engineer. And that was, again, one of my big frustrations. And this is something that we see on, you know, the systems engineering subreddit pretty frequently, is this frustration. Is like, I used to do engineering, but now I'm a document tracker who occasionally gets to do engineering. And I don't want that for us. That's not why we became engineers. But more and more with the increasing complexity of our systems, it's becoming a case where we have to put that engineering, you know, desire aside to hunt down the traces and fix documents and find the version of the thing. And you know, we need more than that. We need more than that. And beyond just our own desire to make things and engineer and contribute, there's a greater danger lurking underneath the inability to wrangle the complexity that we've got here. So if we make a change to a sensor tolerance in this example, right, thinking about change cascades through systems, um, we update one sensor tolerance in a requirement somewhere, and it's from plus or minus zero point 0.5 to plus or minus zero point 0.3% across the operating temperature range, and it's just one requirement. Sounds manageable, but when we
You do
examine
the
what
impact
happens,
analysis.
yeah, when we start doing the impact analysis, exactly, we start to see what opens up. A single tolerance update touches the test cases attached to the sensor, subsystem requirements upstream, the interfaces, the safety requirements, because the sensor provides the safety critical data and a firmware spec, and the firmware spec itself is what implements that. And so, again, all of this ties into each other. And unless you've got someone like ticking down the line of every permutation of every network impact this could have, or have a capability of doing that automatically, um, a lot of these cases can go unnoticed or could go under-realized in terms of what the risk is to the development of the system, or its capabilities. And in a lot of teams, in a lot of cases, these connections are implied. Occasionally they're formalized, but I don't think I've ever seen a case where they were fully complete. And um, and someone knows that the connection exists, and we do a good job running each other down and figuring it out by hand. But it's 2026, man. This is the future. We've got to be a better way to feel confident that we can run these network questions down and these impact analysis down to ground across these vast networks of data. Um, and here's the thing too, is the person who made the original change might not even know that those dependencies exist. Like, you've got to be able to surface that there are these dependencies in the first place. And that relies on being able to create a network of information that is robust enough to surface that kind of content at the point of service. And then the people responsible for those downstream artifacts might not hear about it for a while. And, all of a sudden we're rolling weeks and weeks past when things should have been done because there's uncertainty, or maybe we just didn't even know it all and kept trucking along. And all of a sudden we've got a quality escape. And it wasn't really through negligence. It's just an invisible, unmanned, and incomplete connection. And so it looks tidy and nice on the slide, but in a lot of cases it can end up being something that is really messy and very human. And so we've got one change with 20 or more downstream impacts, and most of the tooling isn't going to show you that, certainly not in an actionable way. And this is how a lot of tools tend to represent requirements, and it's a natural way of thinking about it, right? Like, I love Excel as much as the rest of us. It's a powerful, versatile, capable tool, and it's easy to get into. But there's a limitation to it in terms of how we present what's going on with the requirements and where the issues are. So you look at this requirements table, the ID, requirement text, verification method status. It's clean, structured, looks under control, but it's lying to us, right? It doesn't show us that system requirements 001 and 4 are connected. 003, the IEC 61508 compliance requirement touches every single other requirement on the list. And if you're looking at that, you have the domain expertise, sure, it's obvious. But is it obvious to everybody? Is it obvious to the firmware engineer, to the software engineer who, doesn't handle that type of compliance? 006 firmware timing has implications for 002. And so it looks structured, it looks complete, it looks like we've got things under control, but the interconnectedness, the complexity that arises from that interconnectedness is lurking under the surface. It gives us the illusion of structure, but it doesn't give us the system. So the traceability is a network. It's not rows. It's relationships between different things. This is something that really resonated with me when I started studying model-based systems engineering. It made sense intuitively to me that thinking about systems was inherently thinking about how things are related to each other, and what the interplay is between different pieces of equipment, different software, et cetera. And this is what those same tabled relationships look like when you model them, accurately based on relationships and not rows, not attributes. Because the thing is, the system already exists as a network. We just don't show it in that spreadsheet view. And when you're making decisions in a row-based view about a network-based reality, you're going to miss things. And that's the core insight behind, like I said, model-based systems engineering. And why I think the best teams are moving away from those document-centered approaches, just because of necessity. You get more insight from a network of relationships. But it's difficult to build out, though. It takes a lot of understanding, skill, and in many cases knowledge of the tool you're using to squeeze that network graph out of there, and then conform it into a useful capability. But let's step back and look at what the document-centric approach gets us, right? This is our CDR sprint. 2 days before CDR, and suddenly the team is scrambling because the trace matrix needs updating, a story that I'm sure none of us have encountered before. And there's a broken link, 004 to test 12. 12 requirements still have TBDs on the verification method. Nobody can figure out if it's spec 3 or 4. And the ICD got updated and nobody told the systems team, which is like, has never happened. And it's not, thing is too, is like, people always want to blame somebody, but it's not a failure of individual engineers. It's not a failure of a person or a team. Like, all of them are competent engineers, right? It's a process failure. It's a tool failure. It's the inevitable result of trying to manage a network with rows. And the review prep work should just be a check. It shouldn't be a fire drill. It shouldn't be something that like gets us out of our lane thinking about the system and thinking about, all of these specific review artifacts that we've got to generate. And the thing is too is like once you present it, like, do you feel it fully trust it? I mean, you hope it's right, but there's a difference between hoping and being confident. And the tooling should support that. Um, and so yeah, the blind change, the mechanics of how this goes wrong in real time. We get that 1004 tolerance requirement we are talking about, and then the hidden impacts hit. We see that two items are affected directly, and this is that, again, an impact analysis. Um, and it's a lot of hidden work, right? You've got to create these connections between everything, because they just exist in our heads until we write them down. And then once someone's written them down, they have to be in a form that makes them actionable, some kind of data structure, something like this. And historically, those structures have been difficult to architect and build and scale. And the thing is when we don't do that because of the upfront difficulty, the upfront investment, when that test fails, it becomes much, much more difficult to trace your way all the way back up to that requirement because it doesn't follow, because there's no thread connecting from one place to another. So you can tug on it, but it'll just come loose. And then you're left, scrambling, trying to find what or who or where related to this kind of thing. And this was something that we dealt with pretty regularly at Anduril, right? Like we would be doing flight tests every week and then scrambling to process that flight test data, do RCCAs, that kind of thing. And a lot of times it could take 2 weeks to process that data because there was just so much of it. And the interconnects that we needed to understand that data didn't exist. And if they had, we would have been able to pull the information together, and maybe it still would have taken some time to come to the conclusions, but we would have surfaced the information much more quickly. And I think that's a lot of the battle that we're fighting in a modern engineering context. But this is something that is not exclusive to autonomous flight. This happens all over the place. During integration or testing, or worse in the field, something fails and the failure mode traces back, and it takes time to understand how it propagates back through that system data. And it's largely the mechanism behind a lot of quality escapes, particularly in complex programs. And the real cost is in numbers. U.S. businesses lose an estimated $30 billion per year to requirements errors alone. And that's not rework, that's just specifically requirements. And you got to still fix the things. And then fixing a requirements error in integration is 78 times more expensive than fixing it at the requirement stage. I think we're probably all familiar with that NASA chart, with their programs. And not every program is a NASA program, but fundamentally, human beings build things pretty much the same way. Like we all build stuff like people. And so whether it's a big program or a little program, like the way we think about attacking it is similar, has similar threads and scales kind of similarly. So, a little problem at the requirements part of the V becomes a big problem in implementation, and then when you get it out into the field, regardless of whether you're NASA or you're a small startup. And you flip it around, you think, okay, well, what happens when we have clear requirements? 97% are more likely to succeed, and that's not marginally; it's almost certain. And that's particularly relative to the teams without clear requirements. And that's the business case for investing in requirements quality. It's not overhead; it's an insurance, and it pays out at every stage of the program. And this was the case with the model that I built at GTRI. Right, I knew that the requirements couldn't be meaningfully understood on a piece of paper or in a document or a spreadsheet. I needed to create that network, tie it into what we were building or the representation of what we were building. And during integration, my test team took, you know, 10, like literally 10 minutes to find something that would have taken a week to solve before, because we had modeled it out. And like, yeah, it took me a long time to make that model. It was a very painful and rigorous process. Um, but at the end of the day, it paid dividends because we stayed on schedule. We didn't have to go and pull everything apart to find where the problem was. And we could continue to move forward through integration successfully. And so these are the kind of things that, we benefit from by creating these interconnected networks and relationships between pieces of information. It feels like a lot of upfront work, and a lot of times we feel like we can't slow down to do it. But in my view, that just means that we need a faster way to do it, so we can keep pace. But now we're going to go into a little bit of a case study about requirements, and this one hits close to home for me. It's one of those things that as an engineer, I think keeps me up at night, and I think especially the systems engineer thinking about what the actual cost of bad requirements is, and this is what it looks like at scale. This is 737 Max, right? Like in 2015, the Boeing engineers flagged a single sensor vulnerability with MCAS. And they wrote it down. There's documentation, but the requirement change wasn't made. MCAS was certified and entered service in 2017, and the system still read from a single angle of attack sensor, and there's no redundancy in place. And then in 2018, it crashed a plane, and then 5 months later, crashed another one. And the entire fleet was grounded 18 months, the longest grounding of any U.S. designed aircraft in history. And that led to $20 billion in total costs to Boeing. $40 billion in market cap was wiped out, and $2.5 billion in legal settlements. But most importantly, and more importantly than any of that, 346 people were killed. And the root cause wasn't a bad requirement; it was a missing one. It was inadequate risk mitigation. Single sentence nobody wrote, and an impact that wasn't traced until it was too late. And this is the value that traceability, those impact analyses, and connecting things together can have. I spent a lot of time reflecting on these kinds of case studies, because as engineers, I think it's important that we understand the context of our work and the environment it lives in and the impact it has on people, because ultimately we're making things for people. And so it's an impactful case study to me. It's resonated, but it's certainly not the only one, and certainly not the only learning point. And the thing that gets me to is a requirement existed, right? Like the engineers knew what was going on. They reported it. They did their due diligence. It wasn't wrong to use the AOA sensor data to correct pitch. They didn't specify what happens when it fails. What happens if the pilots hadn't received the risk mitigation training? What happens if they forgot the training in emergency? There wasn't any redundancy requirement. And a faulty reading could command a nosedive, and there was nothing the system could do to prevent it. In a connected model, the gap is made visible. It's obvious. It shows up as a missing node, a hole in the matrix, and you can't miss it. In a document, in a row, you can miss it. And they did. And that's something that, I'm not satisfied with being the status quo for any longer. And this is why requirements aren't documents. Requirements are systems. It's a fundamental shift, and once you see it, it's hard to unsee. But they're a living, dynamic thing that we have to treat with respect to a system, rather than just the formality of a document. And the solution is what high-performing teams do. It's how they think about things differently. They tend to do 5 things. They store requirements as a connected graph, not in a document. They connect things. Things that don't seem like they should be connected, but they know have an impact. Changes propagate through these connected graphs automatically, and traceability isn't assembled before review. It's maintained continuously. completeness and correctness are a feature, not what you check when it's convenient or mandated. And AI isn't just a writing assistant. It monitors the model, suggests traces, and flags gaps before they compound. The shift from legacy to modern is fundamentally a shift from passive to active requirements management. Documents are passive, models are active, and in this increasingly complex landscape, we have to leverage all of the technology we can to understand that active requirements environment. And so what does good look like? We got 5 practices. We've got maybe just 4 practices. Consolidated efficiency. Model-based requirements, right? I've mentioned this a little bit before, but this is something that I believe in really strongly. Every requirement component in test is a node in a graph, right? Like whether it exists formally or not, it's a relationship graph. And when something changes, if you do have that formalized, everything downstream can know immediately. Not after a meeting, not after someone manually updates 5 documents. It can know now. That can shift validation left, right? Requirements are reviewed for completeness, testability, and conflicts before the work starts, or alongside the work executing. New issues with execution can feed back into that. But this isn't something that happens after integration or during integration. It's not during flight tests. And the goal is to catch the issues out before they become those scaled problems that are super expensive and can have, costs in human lives down the line. Automated traceability is another aspect, right? The link between a requirement and its design artifacts, implementation, and tests are always maintained. No one manually updates a matrix. It's just always updating. And real-time change impact. Right before you approve a change, you see exactly what it touches. Not a list of documents, the actual things that are impacted, the ripple before the wave. And that's the key to these kinds of interconnected relationship graphs. And this is fundamentally why I joined TraceBase, right? Like I've been trying to build this tool for ages. I believe in systems engineering needing to leverage the advantages of AI as a tool, and traceability as a platform, but it needs to be oriented towards how we do work, towards the rigor we need in the work that we do. And with a graph with a graph view of the requirements and system data, traceability is live and not assembled. Change impact analysis can be automated. AI can flag what's broken and help you create requirements that aren't starting from scratch, and monitors quality continuously. And for teams, they're serious about requirements management. This is what a purpose-built tool is like. And it's again something that I tried to make myself, but I'm really glad I met people who are smarter than me, who could help bring us there. And yeah, so a little bit of a pitch there at the end, but I joined this team because I want to bring systems engineering and requirements management into the future. If everybody else gets these cool, fancy tools, with CAD and AI and all this stuff baked in. And, I want a cool, fancy tool, but I want a tool that solves the problems that we face on a day-to-day basis. And I'm happy that I landed with TraceBase because it's a tool I wish I could have built. So if you're feeling friction in the process, if there's a bit of chaos or invisible change impacts creeping up on you, if you want to vent, I'd love to chat. But I appreciate you all listening to the presentation, and we can chat a little bit if anyone's got questions.
Excellent. Thank you very much, Matt. And by the way, thank you very. I had asked, to not make it commercial, to make this, a practitioner's talk. Thank you for doing that. But that rule doesn't apply to me. I can make it commercial. So I'm just going to ask you, if anybody does have questions about trace space, reach out to Matt, reach out to Amanda, who's in this call, or Giannis. But could you just give us just a quick overview? And Matt didn't prepare for this, so I'm kind of just this is kind of a cold call question, but can you just give us an overview on trace space? I just want to
Yeah.
understand this, the tool. What is it? What can it do for me? How does it, in terms of tool integration, how does it work with other tools? And by the way, Amanda put her contact info in the meeting chat. But yeah, just a quick overview, if you could, please, Matt.
Yeah, absolutely. So it's the first AI native and agentic requirements management tool. What that means is that the tool was built from the ground up to use AI in a smart way. So the idea being that there's nothing going on underneath the surface that the AI isn't surfacing to the user. And so fundamentally, I can do everything the AI does if I wanted to in trace space. I could do it manually, right? We have traceability matrices. We've got save filters for tabular views. We've got a classic document view, review process baselines. But the key is, and this is what I liked from the start, was the integration of AI as that assistant that has access to everything in a structured way. And so that's fundamentally the design principle behind the tool is integrating AI in a as repeatable way as possible that doesn't bypass the systems engineer, but supports their workflow by surfacing information as immediately and quickly as possible and making it as actionable as possible across as many surfaces as you can get.
Okay. A further question to that, many of us, sometimes there's distrust of AI, right? Can I believe what I'm being told? That's one aspect. Another aspect is proprietary information. If you have any controlled goods or confidential information, you don't want to share it, right? Well, we're not permitted to share it.
Yep.
Now, how do you overcome that? Can you have a contained LLM, or like how do you work out the that
Yeah. Yeah,
proprietary
absolutely.
nature?
Yeah, that's something that's really important to us from this, and it has been important from the start. We offer access to several different types of trace-based environments. So you can have public cloud, you can have private cloud, or you can have on-premises deployments. And the way that our AI works in the tool is the LLM is the engine, but it's not the tool itself. So you can plug in any LLM that you want into the tool, and it avails itself of the system prompts and the bespoke tooling to access the backend data and trace space. And so regardless of what LLM you're using, you could take an in-house developed tool, LLM that's air gapped from public servers and plug it into trace space and dump in your data and go. And it would be comparable to running it in an AWS cloud server.
See, okay, good. I'll open up the floor here to anybody who wants to ask a question. Maybe what we'll do, we do have quite a few people here on the call. Maybe if you could raise your hand and I'll just call your name to unmute, or put your question in the chat and I'll read it out for you. Okay, first question, Lou.
Yes. What is the oh, by the way, you mentioned Ivy Hooks. I worked for Ivy Hooks for 20 years. She's my boss. I taught classes on customer-centered products. Was the main textbook. Awesome. So it was interesting you added that. Oh, and a sad thing, she passed away last month.
Oh, that's so sad.
Yeah, she lived here in Houston, where I do, North Houston. For that, but the question I had is, how does TradeSpace implement the rules for the guide to writing requirements for requirement quality? Because
Yeah, so that's
I noticed that the requirements on page 5 were not well formed. So I was just wondering,
Yeah.
how you enforce those rules.
Yeah, no, this is a great question. We actually have quality checks integrated into the tool. And so, I think right now we've got a set of like 34 in COSI, like best practices for requirements, and then EARS guidelines as well. And so those are the like system native ones. And then you could customize and tailor the like specific prompts for or system prompts for the quality checks. And so the way it works is the system will tick down that checklist and say, oh, semantically, this doesn't really match this pattern. This doesn't really match this pattern. This feels like it, and a lot of times it requires a bit of iteration. But the fact that we can have it look at those checks before it creates a requirement or suggests a change is something that I've found a lot of value. In fact, I take it for granted, um, and sometimes I have to turn the checks off so that I remember how to write my requirements well. But yeah, we've tried to build that in from the ground up in terms of making sure that if a new systems engineer is using the AI to build out a set of requirements, that they're starting from a better place than they might have without those quality checks integrated.
Yeah, I found that AI and a lot of the tools is very good at identifying defects, but it's not able to write defect-free requirements. And so I have to point out to it defects.
Yeah,
I haven't seen an AI that could write a good set of requirements on its own
yeah,
without the interaction of a human for that.
yeah, and I mean, I'll 100% agree with that. Like I've built out a ton of like demo spaces and sandboxes for clients and prospective clients in the tool, and like yeah, the even with the guardrails or the system prompts or the capabilities that we built into TraceBase, you still need a human eye on the requirements, and that's why I think systems engineering is not really going anywhere, because there's a nuance that decades of experience will provide in the review of those requirements that you just won't get from an AI. But you can move the needle a little closer. And in a lot of cases, I've been pleasantly surprised, if not by the quality of the individual requirement, then by the scope of the requirements it suggests. Things like safety or maintainability considerations I might not have thought of, because I was so focused in on the functionality of the thing that I was working on. So there are advantages there too that I think are helpful, but 100% agree that we're always going to need a person in the loop.
Yeah. Well, system engineering, it's often been said, is a science, but it's also an art. And yeah, so we're not going to be losing our jobs anytime soon. You're right. Hey,
Yeah.
Matt, so now further to Lou's question. It is customizable then. So can you give it, okay, so you can give it something straight from Incosi. I've developed at the place I work, we've developed our own requirement standards. So it's a rule set. We can feed that in here then.
Yes. Yeah. The
Oh, very
structure
good.
exists, and we've got a fully documented REST API that allows additional customization. So, if there's a style guide that exists on like GitHub that you maintain because it's a LaTeX document, um, you could have an integration between TraceBase and that document, and then it would reference that as it does its AI calls. And if it's something that you wanted to integrate directly into the UI, so that it's toggleable, which rules were applied, this is something that this is the kind of feedback that our product team is usually pretty excited to hear about.
Excellent. Okay, we have a question in the chat. I'll just read it out. How does your AI tooling integrate with SysML v2? Can it auto-generate block activity or state machine fragments from requirements text? There's a few questions here. did you want to, should I just read them all and then we'll go back?
That's
Okay,
such a
so
good question.
let's do that. Then we can come back. I'll read them all and then we can come back. I'll reread the first question. So can it auto-generate
Perfect.
block activity or state machine fragments from requirements text? Does it round trip safely back to the model, or is it suggestion only? And how does it interact with Cameo, Capella, Rhapsody, IBM Engineering Lifecycle Management?
Those are your questions. Okay,
It's three
so
questions. So
yeah,
the
and you're gonna
auto-generate block activity and
yes.
state
So
machine.
it's not SysML version 2, although I have kicked around the idea of modeling SysML version 2 with our type structure. We follow a similar type of model-based approach, and so it's not a stretch that you could create an analog that would then sync to a SysML version 2 model fairly in a fairly straightforward way. I haven't broken the tool trying to do that yet. But it's not out of the scope of what is possible with the foundational structure of the tool. That said, it is requirements management, first of all, and that's a little out of scope for where our development is at the moment, but it's something that we've been thinking about. Um, that said, we've got mermaid diagram capabilities integrated into the tool. This is something that I've started to rely on a lot more. I didn't know what mermaid diagrams were until a year or two ago, and so our AI will produce those diagrams and it will suggest items with mermaid diagrams embedded in them that are visible in the tool. So not quite SysML version 2 in terms of, or SysML version 1 here in terms of the like data model rigor of the diagram generation. But better than hand jamming it on a whiteboard or trying to get Claude to do it, with just the desktop app.
Okay.
Second question.
Yeah, does it round trip safely back to the model?
Round trip safely back to the model. Trying to understand the context of that question, because that could mean a lot of different things.
Yeah, the individual who asked the question, you're welcome to unmute and join in the conversation. Maybe we'll just jump to the third question. How does it interact with Cameo, Capella, Rhapsody, IBM, ELM?
So my fantasy is that it replaces all of that. We're still a little ways away from replacing Cameo. And realistically, like if you've done all your work in a tool for a long time, there's no illusion as to there's going to be a migration process, right? There's going to be a process moving from one to another. There's going to be training that has to occur. And so the reason we have a well-documented API is because we don't want there to be an obstacle between our tool and getting it integrated with a customer's tooling stack. And one of the challenges, at least that I routinely had as a systems engineer, was like getting tools integrated together. And this is another aspect of what drew me to TraceSpace was we can provide the customer with more capabilities via our API than we can in the UI. And that's something that I like to advertise in my sandbox discussions with the customer, because maybe the customer only wants to use the tool that they've got in their stack and just needs a system of record that they can audit based off of, and is an event-based, series sequenced structure that they can use in those regulatory contexts or in a specific traceability context. And so that's fine. We will work with that customer to identify the best way to integrate with their tooling. But the thing is the integration is never an easy process, but that is a nature of just the kinds of tools that we work with and the way that we do engineering. Everybody's kind of got a different name for something, and so that's where I come in. And a lot of the work that I do is essentially sitting at the desk of our clients and saying, okay, What do you actually want to do with the tool? What do you need it to integrate with, and how can I get that to you?
Mm-hmm. Okay. Hey, a question regarding the example you gave with the Boeing failed sensor, the angle of attack sensor. Um, so what immediately came to mind for me was, a fault tree analysis or what have you to ensure that you've implemented the appropriate redundancies and that there'd be safety cases that would come out of that, which would result in requirements and development and test, et cetera. Um, do you interface with any fault tree analysis tools or other tools off that nature that could help you in your analysis of your requirements to uncover these gaps where you don't have redundancy but need it for a safety case?
Yeah, God, that's such a good question. We haven't had a client that has directly asked us to implement that integration to date, but it's something that's again been top of mind for me since I joined the company. And realistically, the route there is again via the API. Like I find myself relying on it a lot to integrate with that kind of external tooling, and fundamentally it means parameterizing values in trace space so that you can track the outputs from that fault tree analysis capability in trace space alongside your requirements. So you create this almost bidirectional sync between the two that allows you to surface the outcomes of those analyses, where your requirements are, or vice versa, if you can get your requirements into the tool.
Okay, yeah, thank you. Any other questions? Monica.
Hi there. Yes, I'm Monica. Hey, I'm kind of from the old side. Basically, I've been the doors administrator for many years, and the projects I've worked on, we always had good, strong processes to kind of like alleviate a lot of the issues that you talked about. But even and highly encouraging people to create the links when they create the requirements and fill in the attributes and not come back later, because when they come back 5 minutes later, 5 months later, they can't remember what they did. Anyways, at the time. Anyway, so in that regards, as long as they're following the processes, and then you have the traceability and you can do the impact analysis easily enough to find where the issues are for change requirements and such. But as you say, people are people. They get busy, they get on other things, and then trying to figure out what they need to do to get back in the doors. Now, as you say, a lot of things are shifting now to like things like Cameo, TraceSpace, whatever. I need to shift myself too. But the other thing I'm looking at is where I can help a company with transitioning their stuff from, say, doors to Cameo, to TraceSpace, to whatever. You mentioned that you do have capability. Would it be something like a regIF file that you would potentially move from doors to TraceSpace?
Yeah, we support recIF imports natively, CSVs, docx. I can make you an Excel integration. PDF gets a little tricky because sometimes they're pictures and sometimes they're indexed, and it becomes a whole thing. But I what you said about processes really resonates with me too. Is like, fundamentally, these are the processes of building things, right? Human beings build things in a common process. We might call it agile, we might call it waterfall, but fundamentally, we put stuff together and we see if it works. And so, the way that we want to integrate TraceSpace with other legacy platforms or with people who have processes that are well established is not to rip out that root and stem, but integrate it alongside that and get it to work the way that you do work. And that's the way we approach integrations as well. So if you need recIF imports, we'll get you recIF imports because that's what you understand. If you need to define a clear process for how you would implement the tool, then that's what we get you. The point is to accelerate what works for you and get you onto that local maximum.
I guess I had a couple other quick questions. One, when I think of requirements being included with the models, I think of requirements as being scattered all through the models, and like how do you pull it all together to make a like, so yes, requirements are part of the system, but a lot of people require documents out of that. Like how do you extract the requirements from the tool into a set of requirements, whether it's like a spreadsheet format or whatever, like what you see
Yeah.
indoors or what you see. And with respect to Excel, my last project, I actually got to transition to learning Doors Next. And but because we didn't have the tool yet, we actually had to set up spreadsheets in Excel to allow everyone to work the requirements there, and then I imported it into Doors. But
Yeah.
anyways,
Yep.
so that was one question. The other question I had, quick question I had, then I can let you continue, is you kind of, I may have heard it sounds like you said that you have a 9 to 5 job, but you're also working the Trace Space. I was trying to figure out if Trace Space is a quote company that's creating this tool, like say Cameo or like Dassault, I mean, whatever, or is it more almost like a big working group type thing where people are channeling, helping, solving problems?
Yeah, no. So we're a company. This is my job is a full time at Trace, and I'm just our tame systems engineer on the team. So I work with you know people who are solving real problems like you all, and trying to make requirements a little less painful and a little more modern. And because I wish I had had it, and like I said, I tried to build the tool a couple of times, and but yeah, no, I mean that's it's a real place where we're really doing things, and we want to get as many people in there because ultimately the tool is meant to service the practitioner, right? Like if it's not adding value to the work that we're doing, then something's off.
Yeah. Yeah, you need to have the tools supporting the team and
Yeah,
not forcing people to do stuff that they don't feel productive.
exactly. No, that's exactly right.
Mhm.
Exactly right.
It's easy for the SE to become a requirements jockey. And as you said in one of your earlier slides, we're trying to make time so the SE can do what's more exciting, what they want to do, the design, system level design, architecture, etc. Beruz has a question. I'm going to read it out here. I know we're just a little bit over time, but we're just going to go at least this one more question. How much does the user have visibility over inner workings of trace space and how it manipulates requirements? Or how easy is it to audit the process?
So that's a really good question. The AI will never do anything without explicit approval from the user. So the way it works right now is in the chat, I will work with the AI to write a set of requirements or review a set of requirements, or assess the coverage or traceability or do an impact analysis. And the AI will present me with options. It will present me with
Oh,
change suggestions. But it's specifically inhibited from making those changes itself, because one of the foundational principles of the design of TraceSpace is that the human's in the loop. So, it's a little bit more tedious doing it that way, but it's a tedium that I'm kind of okay with because I'm a little paranoid myself, and I'm a little bit of a control freak, and I like to know what's being added to my system and taken away from it and changed. But if you do accept, a bunch of requirements that the AI generates, and you're like, oh crap, I meant to do this and I did that, and trace this and I meant to trace that. We've got the tools to surface those same analyses or present those same queries in a manual way. So, your traceability matrix is very, very similar to the dependency matrix in Cameo. You can use filters to scope your rows and columns, save filters, same kind of thing. If I wanted to see all stakeholder requirements with a failed test, this is something that you could surface and validate that the AI has actually produced a comparable result, or ideally should be the exact same result. So we have made it. We've created several different surfaces where you could work as a systems engineer without ever touching the AI in TraceSpace very successfully, and you could use those surfaces to audit its outcomes as well.
Good, good. Bruce goes on in the question. So also, do you have plans for hazard log management or even integrating safety certification processes into TraceSpace?
Oh, that's a good question. This is a question that comes up a lot, and I can't speak to whether we have explicit plans for it, but it comes up enough that it is top of mind for us as we discuss how customers want to work in the tool. The beauty of the way the tool works, though, is I can create the framework that is necessary to support the development of that process, or the outlay of the data you need as an input to that process. So, for example, if I need to import standards that I need to trace to all of my development work, or if I want to be able to audit those standards and their traceability to our test cases, that's just a different configuration of TraceSpace that is functionally the same to create as any other configuration because of how we've built the tool. So we haven't pushed that as a default configuration that comes out of the box, but that's also part of the work that I do with the team is sitting at the desk with you and figuring out what you need and getting it in there.
Okay. Yeah, because there's you're getting thumbs up from Beirut, so I think you've answered his question. Yeah, with functional safety, application safety critical, airworthiness, etc. These were important aspects. Something I've been playing with myself just on the side is you mentioned standards, so that kind of rung a bell for me. Taking standards, requirements, test cases, test specs, design data, and trying to use AI to assess whether or not I have the right requirements to satisfy the standard. Are there gaps? Do I have the right tests? So tests to verify my requirements, but tests that will ensure compliance with these standards. Now, TraceSpace, does it do all of this out of the box fairly easily, or do you have to? How do you customize it, I guess?
Yeah, no, it depends on the volume of information and the form of the information that you're using. For example, I'm currently working on a mock-up of a CubeSat, right? And the idea is I want to import several NASA specs. I want to import a couple of university specs for CubeSats, and use the AI exactly as you're describing. Is okay, here are my standards. Let's look at the requirements that I've got for the system, and let's pick out where the holes are against all of these standards or specifications or regulatory concerns. And so even if I just brought in and imported that document from the raw spec, I could use the AI to pull it apart, tease out the nuances in the requirements and break them into their own items and create a more granular traceability structure from there. Again, all stuff that I would want to review with a team and make sure that there's a human applying some wisdom to the context that we're working in. But from a processing standpoint, what would have taken me, to do manually ages in terms of reviewing hundreds of pages of documents, trying to break them into meaningful requirements, and then tracing them back into the system. Maybe takes an afternoon to a week, depending on the volume of the data and the form it comes in. So the speed at which you can approach integrating those standards with your requirements and other design documentation is surprising to me and has been a welcome surprise at that.
Good, good. Okay, we'll take, I see Haroon has his hand up, so we'll make this our last question. So go ahead, Haroon.
Thanks, Ivan. My question is about the AI feature itself. Is it a custom-built in-house system, or can you swap in commercially available ones like ChatGPT or Claude? Can you interchange them? Can you export? Essentially, what's the mobility of that piece of the puzzle?
Yeah, no, that's a great question. And so the idea is that you have access to all the flagship models out of the box. So if you've got a deployment of TraceSpace on an AWS server, for example, you'll have access to ChatGPT, Claude, each rung of each of those models. If you wanted to do an on-prem deployment, right, and air gap your TraceSpace instance, if you have a locally sourced or a locally hosted LLM that you've cooked up on your servers, this is something that we have hooks for in the tool to integrate with our system. And so our system is essentially the frame, the upholstery, the seats, the steering wheel, the axles, the LLM is the engine. So it drives the system, but there are bespoke features surrounding that focus it on the requirements and systems engineering components of our work.
Good. Well, thank you, Matt. I think we should stop the call now. We're over time. Much appreciated. Once again, if anybody wants to reach out directly to Matt or to TraceSpace, you can do so through matt.mclean at trace.space. Is that correct?
It's just Matt at trace.space.
Matt, oh, sorry, Matt at
We're very
trace.space
informal.
or Amanda at trace.space. Now, this recording will be available on the NCOSE Canada chapter website, and this being a special presentation, it will also be available through TraceSpace on TraceSpace's website. So, please feel free to pass it on to anybody who may be interested and wasn't able to attend. Our next event for the NCOSE Canada chapter will be this Friday in Toronto live. We have the Transportation and Infrastructure Workshop, so that should be an exciting time. So just in closing, I want to thank you once again, Matt. Thank you, Amanda. I know you're out there somewhere for organizing this, and I hope to see everybody at the next NCOSE event. Take care, and have a good evening, everybody.
Have a great one. Bye, everybody.